So the first thing we want to look at is different rules of exponents. The first rule of exponents is the most basic. It's called the invisibility rule. Basically, whenever a number or variable is written by itself, it has an understood exponent of 1. I always encourage students, when you're working out problems that involve rules of exponent, if it doesn't have an exponent, just go ahead and write a 1 over the top of it. The product rule says that whenever you're multiplying powers of like bases, you want to keep the base and add the exponents. So I'll give you an example down there at the bottom. X squared times x to the 4th, what you're doing is you're adding 2 plus 4, which gives you a total of 6 x's. So that means x to the 6. The quotient rule is the exact opposite. When you are dividing powers of like bases, you want to keep the base and you want to subtract the exponent. So the example I give you is x to the 5th divided by x squared. They have the same base of x, but when they're being divided, you do 5 minus 2 to give you x to the 3rd. So let's look at some examples of these two rules. A to the 5th times a squared. Again, since they have the same base of a, you can add their exponents together, which gives you a to the 7th. Now keep in mind you're still multiplying the two numbers here, so 2 times 4 would give you 8. But when you're dealing with exponents, x squared times x to the 7th gives you x to the 9th. When you have two different variables, you're going to treat them individually. Here's where that invisibility rule comes into play. So m to the 6th times m to the 1st is going to give you m to the 7th. Add those together. And then n squared times n to the 3rd gives you n to the 5th. When we, again, divide, we're going to subtract our exponents. So 12 minus 3 is going to give you x to the 9th. Here, same thing. Treat each one individually. So 18 minus 4 is going to give you m to the 14th. 8 minus 4 is going to give you n to the 4th. We still want to divide our numbers, which is going to give us 9. And then 5 minus 4 is going to give me a to the 1st. Now technically you could write the 1, but we won't because it's invisible. And then 8 minus 5 is going to give you b to the 3rd. Now the power to a power rule states that when you have our base being raised to a power, being raised to another power, we're going to multiply their exponents together. So the example I give you is x squared being raised to the 4th power. So 2 times 4 is going to give you 8. Do not get this confused with the rule that we just did, which was the product rule. That stated when you multiplied with like bases, you add their exponents together. So this was x to the 6th. This is stating when you have an exponent and it's being raised to another exponent, we're going to multiply those together, which is giving you x to the 8th. When you have a product being raised to a power, you're going to treat each one individually being raised to that exponent. So here we're going to do 2 times 3, which is going to give us x to the 6th. And here we're doing 1 times 3, which is going to give us y to the 3rd. When you have a quotient being raised to an exponent, you're going to multiply both that numerator and that denominator by that exponent. So the example I'll give you down here at the bottom, we're doing 3 times 2 for our x's, which is giving us 6. And we're going to do 2 times 2 down here, which is going to give us y to the 4th. So some examples of this, multiplying 3 and 4 is going to give us a to the 12th. We still want to do 4 to the 3rd power. So when you do 4 to the 3rd power, we're going to get 64. So that means, again, 4 times 4 times 4. And then we're going to multiply our exponents. So this is going to be a to the 15th, and this is going to be b to the 9th. Negative 3 squared is going to be negative 3 times negative 3, which is 9. 7 times 2 is going to give us a to the 14th. Again, do your numerator and your denominator separately. So this is going to be x to the 12th. And then 3 times 3 is going to give us y to the 9th. You could go ahead and simplify this initially. A lot of students do like to go ahead and do the product or the power rule first. So this is going to be x to the 3rd. Multiply that is going to give us 24. X to the 3rd at the bottom. And then multiply 4 times 3 is going to give us y to the 12th. Now we would have to use that quotient rule. Now whenever you have the same exact base and exponent both in your numerator and your denominator, they cancel each other. And then 24 minus 12 is going to give us y to the 12th. You could again go ahead and simplify if you want to. I would even probably go ahead and simplify this fraction just to make your exponents a little nicer. You could divide both of these by 2, so that's going to give you 2, and that's going to give you 7. Now we're going to do 2 to the third power, which is going to give us 8. We're going to do 4 times 3, which is going to be x to the 12th. 2 times 3 is going to give us y to the 6th. Down here at the bottom, 7 to the third power, 7 times 7 is 49. 49 times another 7 is going to give us, let's see, 28 plus 6 is going to give us 34, so 343. And then we're going to do x to the 9th and then y to the 3rd. Again, we did that by multiplying all these exponents together. Now, anything being raised to the 0 power is going to equal 1. That's regardless of whether it's a number or whether it's a variable. So 25 to the 0 power is equal to 1. Even if you had like x to the 0 power, that's also going to be equal to 1. When you're dealing with negative exponents, what that means by definition is 1 over that number being raised to the positive exponent. So if you do 5 to the negative 3 power, what that means is 1 over 5 to the third power, which is 1 over 125. So anything raised to a negative exponent is 1 over that number being raised to the positive exponent. So let's look at some examples of this. Now this one is m times n to the negative 4. It's a rule of thumb in math that you never want to leave an answer with a negative exponent. So what's going to happen is this n to the negative 4 is going to drop down to the denominator, and it's going to become n to the positive 4 power. Now this one's a little bit different because the whole thing is in parentheses. So what this means is 6 to the negative 2, and it also means x to the negative 2. Whereas this one, the only thing being raised to the negative exponent was the n, not the m. So what's going to happen is both of these are going to drop down to the denominator to make them positive. So 6 times 6 is going to give us 36. So this would be 1 over 36 and then x squared. The only thing that's being raised to a negative exponent here is the d. So 6c to the third stays as is. And then d squared drops down to the denominator, become positive. Now you could use your power to a power rule here and multiply everything by 4. So this becomes g to the 12th and then g to the negative 8. G to the negative 8 is going to drop down to your denominator to become positive. And then we can actually keep going with this because our quotient rule says that we can subtract these exponents, which is going to be g to the 4th. Now, when you subtract exponents with like bases, before we were just putting everything in the numerator. Now that we know about negative exponents, we've got to decide whether or not our answer is going to go in the numerator or whether or not it's going to go in the denominator. A shortcut that you can use with these is wherever your higher exponent is located, that is where your answer is going to go. So in this case, you have a to the third divided by a to the 5th. So since a to the 5th is my higher exponent, when I subtract these, I know my answer is going to go in the denominator. So 5 minus 3 is 2. So my final answer is going to be 1 over a squared. Again, wherever the higher exponent is located, that's where your answer is going to go. Now 8 over 24 can simplify to 1 over 3, so you do want to reduce any fractions that you have. 4 minus 1 is going to give you 3. My higher exponent is at the top, so a to the third goes at the top. 12 minus 10 gives you 2. Again, higher exponent here is at the bottom, so b squared is going to go at the bottom. 2 over 4 you can reduce down into 1/2. You have nothing to subtract with your x's, so that's just going to stay where it is. 10 minus 8 is going to give you 2. The higher exponent is in my denominator, so y squared is going to go in my denominator. When you have negative exponents already in a fraction, what's happening is it's becoming a fraction divided by a fraction. Because remember, 2 to the negative 2 power technically means 1 over 2 squared. So this whole thing is 1 over 2 squared. Keep in mind when you divide fractions, you end up multiplying by the reciprocal. And so that's just a fancy way of saying you flip the fraction. So to make things kind of simple for you, Whenever you have a negative exponent in a fraction, basically it's just flip-flopping locations and becoming positive. So a to the negative 2 in the numerator becomes a squared in the denominator. A to the negative third in the denominator becomes a to the third in the numerator. So notice they just flip-flop locations. The only time you move exponents, though, is when it's negative. So if they're positive, then you're just going to leave them alone. So 3 minus 2 is going to give me a to the first. Notice I put that in my numerator since my highest one's in the numerator. So we can just write this as a. So let's look at some examples. Now you never want to move negative numbers. That is not a negative exponent. So negative 2 is just going to stay where it is. But what's going to happen is these two here are essentially going to flip-flop locations since they're negative. Y to the third is just going to stay right where it is. So z squared is going to go at the top, and then x to the fifth is going to go at the bottom. Now there's nothing to subtract, so we're done with this problem. Now a to the 12th and a to the 5th are going to stay where they are. The only thing that's going to move here is my negative exponent. So it's going to actually drop down to my denominator to become positive. So using our rules of exponents here, we can subtract our a's, the higher one being at the top. So a to the 7th is going to stay up here. Now these two are side by side, so that means we're multiplying them. So we're going to add those exponents, which is going to be b to the 8th. And then finally, we can reduce 6 over 18 into 1 over 3. I'm going to move my negative exponent, so it's going to come to the top here to become positive. These are going to stay where they are because they're positive. Now we can do a little work here. We can add our exponents together, which is going to be x to the 9th. Subtract, we get y squared. My higher exponent's at the bottom, so y squared is going to go at the bottom. Whenever you have a fraction being raised to a negative exponent, my suggestion is just write everything being raised to that exponent first. Remember, when you have a power to a power, you do want to multiply those. So this is going to be x to the 16th. This is going to be y to the negative 22, multiplying those together. Now to fix this, we're going to move y to the negative 22 and make it positive in my numerator. So this would be my final answer. You do want to be careful when you have numbers. I would just write this as 2 to the negative 3 initially. This is going to be a to the negative 28. Again, I'm multiplying my exponents to get all these. This is going to be a to the negative 6. This is going to be b to the negative 6 as well. To fix all of this, all of these have negative exponents, so basically my numerator is now becoming my denominator, and my denominator is now becoming my numerator. So simplifying this, we would have 2 to the third, which is 8. 2 times 2 times 2. We would do 28 minus 6, which is 22, but our highest exponent's in the denominator, so we'd put a to the 22 in my denominator. 6 minus 3 is 3. Higher one's in the numerator, so I'd put b to the third in the numerator.